So chapter 4 talks a lot about graphing, and what we're going to talk about in chapter 5 is how you deal with systems of equations. Now, we've been talking about specifically one equation up to this point and how you deal with that, how you graph it, how you solve it. Now we're going to talk about multiple equations, how you deal with them, how you graph them, etc., etc. So what we're going to be talking about is how you handle more than one equation at the same time and how you deal with the answers of these set equations when you deal with them. So what I need to talk about specifically is what a system of equations is. And what a system of equations is just basically two or more equations that have something in common. It could be anything, but they are considered together by some sort of reason. So what we need to talk about in this section is how we define them in terms of a solution. A solution for a system is just going to be is a solution that works for every equation in the system. So it's got to work for every single equation that's in the system for it to be a solution. Now when we talk about that, what I mean is that when we have something, we have an ordered pair here, and it's asking us specifically, is this a solution? Well, we have to check it. And we have to check both equations. So we got to check both of these equations for x and y. So I got to check both of the equations for both x and y. So what I have is 2x minus 3y equals 12. So I'm going to plug in x and y and we'll see what happens. I get 2 times 3 minus 3 times negative 2 equals 12. So my answer better work out. 6 plus 6 equals 12. It does. So it works for the first one. We're not done though. So I got to check the second one. 5x plus 2y equals 11. So I got to check the exact same thing for 3 comma negative 2. So I'm going to check the exact same thing. So 5 times 3 plus 2 times negative 2, that better give me 11. Well, let's check. 15 plus a negative 4. Does that give me 11? Yes, it does. So 11. This works for both equations, so it is a solution. I'm not going to write is the solution, but it is a solution. We'll be able to tell how you can find out if it is the only solution later on. So it's just a simple matter of plugging in specific things to determine if something's a solution or not. Now, what I need to talk about now is how you go about finding the process of getting a solution. And the very first process that we talk about is the process of graphing. Since we've done a lot of graphing from the 4th chapter, it only makes sense that we continue to talk about this process in chapter 5. So the first thing that we want to do is we want to graph each equation. So what we want to do is get it so it's solved for y. If it's not solved for y, we deal with solving it for y. Once we have each one solved for y, we are going to find a common point. Now you might say, what does this mean? What does it mean to find a common point? Well, when we graph something, you'll see exactly what it means to have a common point and how it relates to a graph. So I jumped ahead to the next page, and we're going to look at specifically this first example and how you graph something. So I have this first equation. It's not solved for y, so it's not easy to graph. So I'm going to solve it for y right now. So I'm going to subtract this x to get x, or try and get y by itself. So I have 2y equals negative x plus 4. And what I'm left with is this 2y, so I got to divide by 2. So I have y equals, I can't just write negative x over 2, so I'm going to write negative 1/2 x plus 2. So I'm going to graph this. I'm going to start at a positive 2, and I'm going to go down 1 over 2. So those are my 2 points. So I'm going to make a line through them in just a second. I'm going to do the exact same thing with this next one. I can't do this unless I solve for y, so I'm going to subtract 2x first. So I'm left with y equals negative 2x minus 1. So what I have is this equation that starts at negative 1 and goes down 2 to the right 1. So I have 2 lines. I have this first one here that appears to be going like this, and I'm just going to draw arrows on it to complete this line. I have this second line looks like this. Now you might ask, well, now that I graphed them, so what? What does that help us do? Well, as you can see here, these points that are in black are all the points that are on the first line. These are all points on the first line. Okay, so those are all points that are on the very first line. Now for the second one, these are all points on the second line. Now if they're points on the line, they're points that work in the equation. So what we need to do is we need to find specifically a point that works for both. So if we look at this, it appears there's a point that works for both of them. And it's at the point negative 2, 3. So the point negative 2, 3 is on both lines. So since it's on both lines, it's my solution. That is my solution. This is how you write the solution for your system. So again, looking at this again, we want to solve for y. What I want to do is I want to solve for the first one for y. So I'm going to take 2x plus 3y equals 6. I'm going to solve for y. The first thing I need to do is I need to subtract 2x. So I have 3y equals negative 2x plus 6. I'm going to divide by 3. That means I got to divide everything by 3. So I get y equals negative 2/3 x plus 2. So I have my line here. I'm going to start at a positive 2. I'm going to go down 2 to the right 3. So those are 2 points on the line. I'm going to connect them a little bit later. Now I'm going to do the exact same thing with this second line. So I'm going to graph this. I need to solve for y. I'm going to subtract 4x first. So I have 6y equals negative 4x minus 12. I'm going to divide by 6. And I get y equals, I'm going to reduce that to negative 2/3 x minus 2. So here's my first line. Here's my second line. So I'm going to start at a negative 2, go down 2 into the right 3. So what I need to do is I need to make lines going through these points. So here's my first one. Here's my second one. Now we have a problem. If I connect, if I try to find a point where they meet, they don't appear to meet. Now I could continue to try and draw these and see if they do meet, but as you can see on the graph, they don't appear to be meeting anytime soon. So the question is, how do we deal with that? What do we do? Is there any way to know for sure where they meet if I continue drawing the graph? Well, they share something in common. This number in front, that's the slope. And when slopes are equal, from the last chapter, we know that lines are parallel. And if lines are parallel, that means that they don't intersect. So they have no common points. And again, a solution is where they meet. And if they don't meet, then this is what's called a system being inconsistent with what you're trying to do. If it's inconsistent, that means there's no solution. It means you can't find a solution based on the fact that their lines are parallel. These lines will never meet.